We will come to subtraction. Okay, it will not hold good. How? You see, 1 minus 2 minus 4. 1 minus 2 minus 4. You create the bracket here. Then we will test 1 minus 2 minus 4. In both the cases, we will see, we will simplify it. 1 minus 2, that is minus 1, minus 4, that is equal to minus 1 plus of minus 4, that is equal to minus 5. But the problem is I cannot use the negative signs here because the whole numbers. We are discussing about the whole numbers. So you will see the value will not be same. 1 minus 2 minus 4 will not be equal to 1 minus 2 minus 4 if I give the brackets here. In both the cases, the value will not be same. And I cannot use the negative signs because we are discussing about the whole numbers. So what we knew, remember students, it is most important because you will feel clumsy, you will feel difficult. Why? You see, there are 4 basic operations, and these are these property, main properties, closure property, commutativity, associativity, and your mind will be crossed here and there, here and there. No, just remember all the whole numbers. So closure property, commutativity and associativity under addition and multiplication. Just to remember. This is most important and this will help you a lot. Already about the integers, we have proved them, their properties, closure property, associativity, commutativity under different basic operations. And exactly the properties of the integers and the properties of the rational numbers in these cases exactly same. So we can write all the integers and rational numbers are closed or slow. So closure property under which operations, which basic operations? Under addition, subtraction and multiplication. So it is for the closure property. All the integers, you remember, all this all is important. Why? I will discuss. Finite division is taken here for the closure property, this operation. Suppose you see, suppose I will take, for example, I will take 2 rational numbers. Suppose one is 1 upon 2 and the next one is 0, that is suppose 0 upon 1. So these are the 2 rational numbers. So I am discussing about the closure property, but I will take the basic operation division. So I have to divide 1 upon 2 divided by 0 upon 1. But it cannot be the divisor. 0 upon 1 means that is 0. 0 cannot be the divisor. Or what it is? Like this. it is the bar, and in the denominator I write 0. You see, this value is 0. 0 upon 1 means 0. 0 cannot be the denominator. We cannot divide a number by 0. So it is not possible. So when it is possible? No, it is possible, but for non-zero rational numbers. Suppose if I take 1 upon 2, 1 upon 3. 1 upon 2 divided by 1 upon 3. That is equal to 1 upon 2 into 3. That is equal to 1 into 3 whole divided by 2 into 1. So that value is 3 upon 2. You see, 3 upon 2 is a rational number because it is in the form P upon Q. Q is not equal to 0. It is a rational number. But here it is not possible because both are non-zero rational numbers. For non-zero rational numbers, the division holds good if you prove the closure property. But here I have taken all. This all is important. So for all rational numbers, when we are discussing about the closure property, we cannot take up these basic operation. Division doesn't hold good. So you remember this and you try on your own. You take suppose 1 upon 2 plus 1 upon 3, then you add. You see, the sum will be rational number. 1 upon 2 minus 1 upon 3 or 1 upon 3 minus 1 upon 2, whatever it may be, the difference will be a rational number. If you multiply, then you see 1 upon 6, it is also a rational number. And this will hold good if the two rational numbers are non-zero. So for the non-zero rational numbers, the division operation will hold good when we are discussing about the closure property. But here we have taken for all rational numbers. So these are basic operation division will not hold good. So my point of saying is this. Now I erase it. Then all the integers and rational numbers. So commutativity, that means commutative property, and associativity. Under addition and multiplication. Only addition and multiplication. Both the property, both commutative property and associative property. Through basic operations, addition and multiplication. You remember this and you prove it. You may take any example. You see, suppose for the commutativity, if I take addition, commutativity, that is the order property, I will change the order of the rational numbers and the basic operation I am taking addition. So 1 upon 2 plus 1 upon 3, that is equal to, you find the result, you do on your own. You will see, if left hand side you add this, the value you will get, that is equal to the sum, that will be equal to, you just add and this sum. Both will be equal because we have taken here the addition operation and we are proving the commutativity. But if you bring the negative sign or subtraction, 1 upon 2 minus of 1 upon 3, that is not equal to 1 upon 3 minus 1 upon 3. So it has been discarded. Only addition and multiplication. In case of multiplication, we see 1 upon 2 into 1 upon 3, that is equal to 1 upon 3 into 1 upon 2. In both the signs, you see the product remains unchanged. So I am getting only addition and multiplication. Once you prove it, once you do on your own, you practice it, you will remember this. It will be helpful when you will have to apply in different applications. When you will solve the problems, you will solve the equation, and you will remember this will be helpful to you. Then comes the division. 1 upon 2, 1 upon 3. That is not equal to 1 upon 3. This will not hold good. You will practice. In case of division, you see the left hand side is equal to 1 upon 2 divided by 1 upon 3. That is equal to. So when you change the sign here, you give the sign for multiplication, then take the reciprocal of 1 upon 3, that is 3 divided by 1. That is equal to 1 into 3, that is 3. 2 into 1, that is 2. So what is right hand side? 1 upon 3 divided by 1 upon 2, that is 1 upon 3. You change the sign, 2 upon 1, that is equal to 1. These twos are not same. This is not same. 3 upon 2 is not equal to 2 upon 3. Then we will come to associativity. So for associative property, for example, we have to take minimum 3 rational numbers. Suppose 1 upon 2, 1 upon 3, 1 upon 4. You do on your own. You add them. You change the grouping of numbers and you add like this. Then you create. The sum will remain unchanged if you change the grouping of numbers. If you change the grouping of numbers, but the sum will be same. So we could prove the associative property taking the basic operation addition. And for subtraction, it doesn't work. How? You see. Again, I change the grouping of number. At least these two. I erase the first here. So finally, the difference we get here, both the differences will not be equal. Both the values will not be equal. You see. Then we will come to that is equal to. So we have to do the bracket work first. So we will have to find the LCM of 2 and 3, that is 6. You know it or not? You will multiply the numbers if they have the common factor 1. Okay, so 2 into 3 is equal to 6, that is the LCM. So you will have to do the bracket work first. So what you will do here? 1 upon 2 into 3, because we have to make the denominator same. Otherwise we cannot add or we cannot subtract. You know, like fractions. So just in that pattern you do. So into 3 minus 1 upon 3, we have to convert into 6, so we have to multiply by 2, then by 2, then give the bracket, minus 1 by 2. That is equal to 3 upon 6 minus 2 upon 6 minus 1 upon 4. That is equal to 6, 3 minus 2, okay, minus 1 upon 4. That is equal to 1 upon 6 minus 1 upon 4. Again we have to take the LCM of 6 and 4. So what is the LCM of 6 and 4? 2 into 3 into 2. So 12. Yes or no? So in each case the denominator we have to make it is convert 6 into 12. So 1 upon 6 into 2 minus of that is equal to 2 upon 12 minus 3 upon 12. Okay? That is equal to the common denominator is 12. So 2 minus that is 2 plus of minus 3, that is equal to minus 1 upon 12. So you see it, and there is no space, I want to erase it. I will have to prove. Okay? So I change the grouping of numbers here. We are just discussing the associative property, and we have taken the basic operation subtraction. That is equal to 1 upon 2 minus, you start the round brackets, and you see find the LCM of 3 and 4 is 12. So convert the 3 into 12. So 1 upon 3 into 4 minus 1 upon 4 into 3. That is equal to 1 by 2 minus 4 upon 12 minus 3 upon 12. That is equal to 1 by 2 minus 12. 4 minus 3. That is equal to 1 upon 2 minus 1 upon 2. So LCM of 2 and 12 is 12, because 12 is the multiple of 2. So that is equal to 1 upon 2 into 6. Here already 12 is here. So take the common denominator 12, that is 6 minus 1, that is equal to 5 upon 12. Yes or no? So you see, the value in both the cases are not same. So all the integers, not only integers, all the rational numbers, they show commutativity and associativity under addition and multiplication. All. And all the integers and rational numbers, they show closure property under 3 basic operations: addition, subtraction, and multiplication. Yes or no? Equivalent rational numbers. A upon B and C upon D. Two rational numbers we took. For example, A upon B and C upon D. So, A upon B is equal to C upon D. When if A into D is equal to B into C. A into D is equal to B into C. So the numerator of the first rational number into the denominator of the second rational number, that should be equal to the denominator of the first rational number into the numerator of the second rational number. So this is the condition. If A into D is equal to B into C, then we can say A upon B is equal to C upon D. Let us take an example. Minus 2 upon 3. 4 upon minus 6. So we will verify whether these two rational numbers are equivalent rational numbers or not. So you see here A into D. Here A is equal to minus 2 and D is equal to minus 6. So minus 2 into minus 6. Already we have known minus into minus, that is plus. 2 into 6, that is 12. P into C, 3 into 4, that is equal to 12. So A into D is equal to B into C. You see, same value here. So minus 2 upon 3 and 4 upon minus 6, both are equivalent rational numbers. Okay.